Hi guys, it's me again. This is part 2, and now we're gonna do homework 14, number 3, okay? Now, if you've made it this far, which of course you have because you're my brilliant students who I love, I encourage you to stand up and stretch and relax, breathe in, breathe out, eat some chocolate, eat some candy. You know how our method works. That's right, all of y'all better be hensing. You know what I'm talking about. I'm gonna stop entertaining myself and start showing you how to do this very difficult and yet actually kind of cool problem. Magnetism is actually one of the coolest things I think in physics. It's a very interesting, it's an everyday example of special relativity as we discussed in class, but we're not going to talk about that right now. Right now we're going to do the homework, okay? So number 3 says, suppose I have a wire with 5 amps in a positive y direction of current running through it. Okay, so I'm going to change all the numbers. So I'm going to make I1, we're going to make it equal, what should we make it equal? Let's make it equal 6 amps, okay? We'll do that today in the y direction, okay? And for A, well, let's make the distance between the wires because we're going to ask about that pretty soon. Instead of 0.02 meters, we'll make it, let's make the distance that we want. We'll make R, we'll make it equal to, let's say 0.03 meters, okay? Awesome. So for part A, it says, okay, we have a wire like so. Okay, and we've got this current running through it. This is I1. Okay, this is of course the positive y direction. Okay, so this is y, and this is x, this is z. Okay, because x cross y is z. Excellent. Okay, now we want to know 0.02 meters away from 0.03 meters away from the wire. So we'll make this. This will be r, and this distance here will have r equals 0.03 meters. And I1 equals 6 amps. I'm not sure if you can see that. It's kind of hard to see. This, of course, in the x direction, or the negative x direction. Doesn't really matter. Can you see that? Okay, looking. Pause now if you want to write this down and copy it. No, it's going on. All right, let's do this. Okay, good. So, we want the resulting magnetic field. Okay, do you guys remember Ampere's law? It's this. It's the integral of B dot dl equals mu naught times I, okay? Now, that is very icky and confusing, I know. But, I mean, this part looks kind of icky and confusing. But don't let it freak you out, okay? Because really, it should not be. I already told you what mu naught equals in class. It's 4 pi times 10 to the negative 7th, I think. I'm not sure. You can look it up yourself. But the point is you should know this, okay? So this equation is what you really need. Now, all that this B dot dl circular thing means is that the B field, okay, kind of becomes a circle around a current. So in this case, right, we have a current going this way. And so you're going to have a circle around the wire, and that's going to be your B field. And that's all this really means is it's a loop. Is you're going to have, we want to know at every point along this loop, the B field is the same. And so if I need to know the B field, it's affected by the distance, the circumference along this circle, okay? So when I want to know the magnitude of a B field, I just choose a circle that comes out to the radius of the distance that I am away, okay? And I know that's a little bit counterintuitive, but if you think about it a little bit, it'll kind of start to make sense, hopefully. So this is really, in this case, the same thing as saying B times 2 pi radius equals mu naught times I, where I is the current running through the circle, okay? So really we write I enclosed usually, okay? So that means that our B field is just going to equal mu naught I enclosed over 2 pi r, okay? This is very important. Now, if you want to know the direction of your B field, all you do is we want to know the direction. I know that I have a circle that's going around the wire, but I want to know what direction the circle is going. And to find that out, I just put my thumb in the direction of I, and my fingers curl around pointing in the direction of B. So since my fingertips are pointing this way, that means I'm going this way, which is going to be like, I don't know if that's clockwise or counterclockwise, depending on how you're looking at it, but they go this way. So it's going to be this way, okay? So I, and then this way is going to be the induced B field, okay? So this is my B. Like so, there's I and there's the induced B. So that means that in this case, at every point, it's going to be different. So if I wanted, let's say I take it at this point, okay? So at this point, my r is in the minus x direction, and that means that my B field is going to be pointing this way. Because remember, at each point, it's like the B field is pointing in the direction traveling along the circle. So at this point, it's going this way. At this point, it's going this way. At this point, it's going this way. And at this point, it's going this way. It's kind of like I've got like a little train set, and like my train is going around this circular track, and whichever way it's facing is the direction of my B field at that moment, okay? So at this point, if that doesn't make sense again, please, please, please don't hesitate to pause, rewind, and if you still have questions, of course, you can email me, you can message me, you can complain to me, Miss Mizrachi, what is going on? That's fine, that's beautiful, that's great. So this is going to equal, okay, mu naught times I, which is going to be 6 amps, okay, divided by 2 pi radius, which is going to be 2 pi times 0.03 meters, okay, and this is here, at this point, it's pointing in the z direction because it's coming out at you, so it's going to be in the z direction, okay. Now, if you actually plug that in, I hope I'm right when I say that I think mu naught, I believe it's equal to 4 pi times 10 to the minus 7th. I hope I'm right. So if that's right, then we're going to get, let's see. We're going to get 2 because the pi's go away, and you're going to get, let's see. Oh shoot, let's see. Yes, I still use calculators, I'm sorry. So you're going to get 2 times 200 times 10 to the minus 7 Tesla in the z direction, which is going to be I think it's going to be like 4 times 10 to the negative 5 Tesla. Okay? Good! Awesome! Okay, excellent. So, that being said, let me just check. I think that's right. I think this might be bigger than that. Let me just hold on. Just hold that thought for one second. Let me see. I'm just going to double check my math and make sure that it's right. Just hold on. I think that's right. Let's see. Yes, that is right. Okay, excellent. That is right. Okay. Tesla times meters per amps. So we're going to end up with Tesla. Yes, okay, excellent. Good. Now we got this. So the B field, okay, at a point 0.03 meters from the wire is going to be 4 times 10 to the minus 5th Tesla, and it's going to point in the z direction. It's going to point out, coming out at you out of the page. Okay, good. So now we want to know for part B, okay, if I've got another wire, so we're going to just draw this again. We have wire 1, and this is going to be wire 2. So this is our original wire, okay, and we've got the current of 6 amps flowing through it, okay, in the y direction. And if I've got I2 with negative 3 amps, so we'll make it negative 2 instead, and it's negative, that means it's going downward, okay? So I2 is negative 2 amps, okay, in the y direction, so it's negative downward. And we're going to have it be 2.0, we'll have it the same distance as before, so R between them is also going to be 0.03 meters, okay? You see that? I think so. Good. Make sure you have a picture. Like, again, we always like to draw a picture, okay? So I want to know, first of all, if the force is attractive or repulsive, okay? I think that's all I actually want to know. So how do I find that out? I don't think I even ask you to find the force, but you could find we'll find the force anyways, just to be fun, okay? So remember, we know how to do this. FB is equal to QV cross B. And we also gave you another equation. I also said that it's equal to L times I cross B, right? Because remember, V is just, I'm just going to prove this very quickly. This is the same thing as Q. This is the same thing as saying Q times delta X over delta T cross B. because remember, that's V is just delta X over delta T, which is the same thing as saying Q over delta T, delta X cross B, okay? Which is the same thing as saying I, because I is Q over T, times delta length times cross B. Now this delta L is a minuscule, infinitely small little piece of the wire going through. But of course, if I want the entire magnetic field, right, I need to know this as the entire length of the wire, not just the DL, okay? This is really DF, but we're not going to deal with that right now. So that means, okay, that what this really equals to is I times the length of the wire cross B, or vice versa, depending on which one you want to use in that direction, okay? But they're both parallel, so they're both in the direction of the wire. So we have the B field at this point, of course, is coming out of the page at you, so it's coming out this way on the wire. Because remember we said it's like a big circle, and so I just happen to choose it to hit out at this one. I'm sorry, my phone. Here we go. Okay. I just happen to choose it coming out at this point in the wire, okay? So if I chose to put my wire here, then it would be going this way or that way, and we're always going to get the same answer, which you'll see why soon. But the point is, so my B field now is going out in the Z direction, and I want the force. So I'm going to take I, which is here, downward, right, because it's going down the wire, right? So here's my hand, down the wire, okay, I, cross B, which is outward, out of the page. I cross B, and so my thumb ends up pointing this way. So it's pointing away from wire number 1, okay? So this is going to be the force B. So the answer is it's going to be repulsive, okay? If that doesn't make sense, please rewind it, ask a friend, work together. I really love when you guys work together. It makes me happy and shep nachas. I'm always shepping nachas, but still, okay, good. So I'm so glad that you see how this works. Now, what I want you to try to do, okay, if you want to find, so we'll say force is repulsive, okay? Good. So what if you want to know the magnitude? Which I didn't ask you to do, but let's say you did anyways, okay? Well, that's going to equal the force, okay? Since everything's perpendicular, I don't have to worry about angles or anything because sine of 90 degrees is always going to be 1. So FB is just going to be QVB. In like the outward direction, so in the repulsive direction. So in this case, it's going to be in like the negative X direction. Okay, but that doesn't really matter as much as just to know that the magnitude is QVB, okay, which is going to equal ILB, okay, in this case, which is equal to 2 amps. We're not using negative because that refers to the direction, times L, which is 2 meters long, times B, which is going to be the magnetic field, which of course we just found is 4 times 10 to the minus 5 Tesla. Okay? So it's just going to equal 16 times 10 to the minus 5 newtons. Okay? And that's it. See, it's not that painful, but once you know how to do it, it's like really, really hard until you know how to do it, and once you know how to do it, it's easy, okay? And again, you guys are amazing, the best students ever, and if you have any problems or questions or get confused, please feel free to call me or message me or email me or whatever you want. I'm available, and please utilize chocolate, utilize your friends, everything and all that's out there for you, and let me know if I can help. All right, Hatzlacha Rabba, and I'll see you guys tomorrow. Bye.